There is a silence in the deep architecture of the night. It is not an empty silence, but a waiting one, a heavy velvet quiet that hangs between the stars. When we look up from the surface of our blue world, we are mostly looking inward. We gaze toward the crowded, bright center of our galactic home. We see the thick bands of the Milky Way arching overhead, a river of diamond dust spilled across the dark. It feels permanent, it feels enclosing, it feels like a fortress of light that wraps around us, keeping the infinite void at bay. But there is another direction. There is a way to look that turns away from the crowded city center of the galaxy. If we turn our back on the supermassive black hole at the core, if we turn our back on the dense spiral arms where stars are born in fire and chaos, we face the edge, we face the thinning dark. We face the coastline of our island universe. For most of human history, and indeed for most of the history of astronomy, our eyes have been drawn to the bright, the hot, and the close. We have studied the nebulae within our own neighborhood. We have mapped the spiral arms that cradle our sun. We have even peered past the edge, skipping over the boundary entirely to look at other galaxies far, far away, the Andromedas, the Triangulums, the swirling whirlpools of distant cosmic oceans. But the edge itself, the physical boundary where our galaxy ends and the great intergalactic void begins, has remained a place of mystery. It is a region of ghosts. It is a region of silence. And for a very long time, it was a region we could not clearly see. Tonight, we begin a long, slow journey to that boundary. We are going to travel away from the warmth of our sun. We are going to drift past the orbit of Neptune, past the scattered icy stones of the Kuiper Belt, and leave our solar system behind. We will float through the interstellar medium, moving outward, always outward, until the stars begin to thin, until the familiar constellations stretch and break, until we reach the place where the Milky Way fades into the nothingness of the great cosmic dark. This is the story of the edge. And it is the story of how a golden eye, floating 1,000,000 miles from Earth, finally turned its gaze toward this lonely frontier to reveal that the edge is not dead, it is not empty, it is a place of ancient secrets where the conditions of the early universe are preserved like a memory in the cold. Let us begin by understanding where we are. Imagine the Milky Way not as a picture in a textbook, but as a vast, rotating city of light. It is a spiral disk, incredibly thin compared to its width, stretching over 100,000 light-years across. We live in the suburbs of this city. Our sun is tucked away in the Orion Arm, a minor spur of stars located about halfway between the frantic, crowded core and the lonely, dark rim. From our vantage point, looking out is difficult. The galaxy is filled with dust, great clouds of molecular gas, the ashes of dead stars, and the nurseries of new ones block our view. This dust acts like a heavy fog. When we try to look toward the edge of the galaxy using visible light, the light our eyes can see, we are often blocked by these curtains of cosmic soot. We see the stars in our immediate neighborhood, but the distant shoreline is hidden from us. But the James Webb Space Telescope does not see like we see. It sees heat. It sees the infrared glow that travels through the dust as if it were glass. And recently, it turned this powerful vision toward the extreme outer galaxy. To understand the magnitude of this, we must first understand the geography of our galaxy. As we travel outward from Earth, the environment changes. In the inner galaxy, where the stars are packed tight, gravity is a chaotic master. Stars jostle one another. Radiation is intense. Elements are abundant. Carbon, oxygen, iron, the gold in our rings, the calcium in our bones. These heavier elements, which astronomers call metals, are the result of generations of stars living and dying. They exploded, scattered their enriched guts into the cosmos, and seeded the next generation. The inner galaxy is a metal-rich place. It is a complex, chemically diverse environment. But as we drift outward, past the Perseus Arm, past the Cygnus Arm, the environment shifts. The stars become fewer. The distances between them stretch into chasms of darkness. The chaotic energy of the core fades to a hum, and chemically, the galaxy changes. The metals, the complex elements, become rare. We are entering the galactic countryside. Here, the material is primitive. It is mostly hydrogen and helium, the pristine stuff of the Big Bang. The complex chemistry required for rocky planets and organic life becomes scarce. For a long time, astronomers believed that this outer rim was a dormant place. They thought that without the rich, heavy elements to help cool gas clouds and trigger collapse, star formation would be impossible, or at least very rare. They imagined the edge of the galaxy as a graveyard, or perhaps a barren wasteland where nothing new ever began. They were wrong. We are drifting now, in our imagination, thousands of light years from Earth. The Sun is just one bright star among many behind us. The band of the Milky Way is no longer a wraparound river. It is becoming a horizon behind us, a glowing wall of light. Ahead lies the void. The darkness here is absolute. The temperature drops. We are approaching a region more than 58,000 light-years from the galactic center. This is the extreme outer galaxy. It is a place of profound solitude. If you were born on a planet orbiting a star here, your night sky would be terrifyingly empty. You would look toward the galaxy and see a distant, luminous wash of light, occupying only half the sky. The other half would be a black abyss, punctuated only by the faint smudges of distant galaxies, millions of light-years away. You would feel, instinctually, that you were standing on the precipice of the world, and yet, in this lonely, metal-poor expanse, something is happening. The James Webb Space Telescope has looked into this darkness and found light. It has found clouds of gas, specifically a region known as the Digel clouds, that are not dormant. They are not dead. They are alive with the violent, beautiful struggle of birth. This is why we have traveled here, to see how stars are born in a place where they technically shouldn't be, to see how nature finds a way to create complexity out of simplicity. The concept of the galactic edge is somewhat fluid. A galaxy doesn't end like a table ends. There is no sharp drop-off. Instead, gravity's hold slowly weakens. The disk of stars flares out like a skirt spun in a dance. The gas becomes thinner and thinner until it merges with the intergalactic medium, the incredibly sparse superparticles that fills the space between galaxies. But before that final dissolution, there is this transition zone. The coastline. Imagine standing on a beach at night. Behind you is the bright, noisy city, the Milky Way core. Ahead of you is the dark ocean, the intergalactic void. The waves lapping at your feet, the place where the sand is wet and shifting, that is where we are now. And just as tidal pools on a beach teem with their own unique life, distinct from the deep ocean and distinct from the dry land, these outer galactic clouds harbor a unique kind of stellar evolution. The Webb telescope has allowed us to zoom into these tidal pools. It has captured images of star clusters forming in conditions that mimic the early universe. Because this region lacks heavy elements, it is a time capsule. It resembles the way our entire galaxy looked billions of years ago, before generations of supernovae enriched the cosmos with iron and dust. By looking at the edge, we are looking at our own past. We are seeing how stars formed when the universe was young, clean, and simple. The silence here is heavy. We float in the vacuum, watching the faint glow of the Digel clouds. They are cold, incredibly cold, hundreds of degrees below zero. Invisible light, they would be shadows against the stars. But through the eyes of the Webb, they are glowing filaments of orange and red, intricate webs of gas stretching across light-years. We see distinct clusters of young stars. They are bursting out of their cocoons, firing jets of material into the surrounding space. These are protostars, stellar infants, screaming their arrival into the quiet of the outer rim. It creates a feeling of profound resilience. Even here, at the limit of the galaxy's power, gravity works its magic. Even here, where the materials are scarce and the cold is absolute, light finds a way to break through. As we linger here, let yourself feel the scale of this distance. The light from these stars at the edge takes tens of thousands of years to reach our eyes on Earth. When we look at them, we are seeing light that began its journey when humans were still painting in caves, when the ice ages held our planet in their grip. This distance is a barrier, but it is also a cushion. It buffers us from the reality of the void. But the Webb telescope has collapsed that distance. It has brought the edge into focus. The edge is not a line, it is a gradient, it is a fading out, it is a whisper that slowly becomes silence. But in that final whisper, there is a story. There is a story of how the Milky Way grew, how it ate smaller galaxies, how it spun itself into a spiral, and how it is still growing, still changing, even at its most distant frontiers. We are drifting along this coastline now. The waves of the galactic disk ripple beneath us. We are explorers at the end of the known world. And just as the ancient mapmakers wrote, "Here be dragons" at the edge of their charts, we have found that the edge of the galaxy is filled with monsters and miracles of its own. But to truly appreciate what we are seeing, to truly understand the images that have traveled back to Earth, we must understand the instrument that captured them. We must understand the golden eye that hangs in the darkness, looking where no one has looked before. The journey to the edge is not just a journey through space, it is a journey through technology. It is a testament to the patience of humanity, waiting decades for a mirror large enough, cold enough, and precise enough to reveal the dim fires burning in the galactic hinterlands. So, let us turn our attention from the target to the tool. Let us drift back inward, just slightly, to the orbit where a honeycomb of gold sits suspended in eternal twilight. To see the faint warmth of the galaxy's edge, we needed an eye that was colder than the space it observed. We needed a machine that could turn its back on the sun, the Earth, and the Moon, and stare unblinking into the deep infrared. This machine is the James Webb Space Telescope. It hangs at a point in space known as Lagrange Point 2, or L2. This is a gravitational parking spot, 1 million miles away from Earth, directly opposite the Sun. It is a lonely outpost. Here, the telescope orbits nothing but a point of balance, dancing in sync with our planet as we circle the star. Webb is a creature of the dark. It is designed to see heat. And to see heat from billions of light years away, or from the dim, cold clouds of the outer Milky Way, the telescope itself must be frozen. If the telescope were warm, its own heat would glow in infrared, blinding its sensitive instruments. It would be like trying to see a firefly while holding a flashlight in your eyes. So, the Webb carries a shield. It is a kite-shaped sun shield, the size of a tennis court, made of 5 layers of a material called kapton. These layers are incredibly thin, coated with aluminum and silicon. They act as a supreme insulator. On the side facing the sun, the shield is hot enough to boil water over 230 degrees Fahrenheit. But on the dark side, the side where the mirrors live, the temperature plunges to minus 3090 degrees Fahrenheit. This temperature difference is the heartbeat of the mission. It allows the 18 hexagonal segments of the primary mirror coated in a microscopic layer of pure gold to gather the faintest whispers of thermal energy from the cosmos. Why gold? It is not for vanity. Gold is the supreme reflector of infrared light. It captures the long wavelengths that silver or aluminum would absorb. It captures the heat signatures of stars hidden behind dust. It captures the glow of the Digel clouds at the edge of the galaxy. When Webb pointed its golden eye toward the extreme outer galaxy, it was doing something unprecedented. Previous telescopes, like Hubble, saw primarily invisible light. They saw the fog we spoke of earlier. They could see the stars, but they couldn't see inside the clouds where the stars were born. Other infrared telescopes like Spitzer could see the heat, but they lacked the resolution. To them, the outer galaxy was a blur, a smudge of ambiguous data. Webb combined the piercing vision of infrared with the razor-sharp resolution of a giant mirror. It turned the blur into a landscape. The images that returned to Earth were breathtaking. They didn't just show stars, they showed the process of the stars. They showed the anatomy of the galactic edge. In the images of the Digel clouds, located in the far outer spiral arms, Webb revealed clusters of young stars that are bursting with activity. We see jets, narrow streams of gas shooting out from the poles of newborn stars. These jets slam into the surrounding molecular clouds, creating shock waves. The shock waves glow. They look like bow waves from a boat moving through dark water. This activity tells us something profound. Star formation is robust. Even out here, where the gas is thin, where the gravity is weak, where the heavy elements are missing, the universe is aggressive in its creativity. The scientists analyzing these images were looking for signs of subsolar metallicity. This is a gentle way of saying starvation. The stars here are starving for the rich nutrients that inner galaxy stars enjoy. They don't have the abundance of cooling agents, dust and heavy atoms that usually help a cloud collapse into a star. And yet, the Webb images show that these stars form anyway. They may even form more efficiently or differently than their city-dwelling cousins. We see distinct nebulas within the clouds. There is a main cluster, bright and raucous, and then smaller subclusters drifting nearby. Webb's instruments, the near-infrared camera NIRCam and the mid-infrared instrument MIRI, allowed us to peer through the outer layers of these clouds. It is like peeling an orange. We peel back the dusty rind and see the segments of fruit inside. We see the protostars, stars that are not quite stars yet. They are still gathering mass, still sucking in gas from their surroundings. They are surrounded by disks of material. In the inner galaxy, these disks would eventually form planets like Earth, Mars, and Jupiter. But here at the edge, that is the great question. Can planets form in the metal-poor wilderness of the outer galaxy? Without the iron to build a core, without the silicon to build a crust, can a world exist? Webb's data hints at the answers. By measuring the light from these disks, by analyzing the way the dust glows, astronomers can estimate how much solid material is available. The initial findings suggest that while rocky planets might be difficult to build here, the process of disk formation is universal. The geometry of birth is the same. Whether you are in the crowded center or the lonely rim, the telescope itself is a silent observer. It has no voice. It sends its data back to Earth as a stream of binary code, traveling across the million miles of void to the deep space network dishes in California, Spain, and Australia. These dishes catch the signal, a faint whisper of radio waves. Back on Earth, in quiet rooms illuminated by computer screens, scientists process this code. They turn the zeros and ones into images, and suddenly, the invisible becomes visible. The dark edge of the galaxy lights up with reds, oranges, and deep indigos. The colors in a Webb image are not fake, but they are translated. We cannot see infrared, our eyes are not built for it. So, scientists assign visible colors to invisible wavelengths. Short infrared waves might be assigned blue, medium waves, green, long waves, red. This translation allows our human brains to comprehend the thermal landscape of the universe. So when we look at the Deagle clouds in the extreme outer galaxy, we are looking at a translation of heat. We are seeing the temperature of the gas. We are seeing the energy of the jets. We are seeing the heartbeat of the star clusters. It is a gentle viewing. The images are static, but the reality they represent is dynamic. These clouds are turbulent, they are collapsing, spinning, heating up. But on the time scale of the universe, it happens in slow motion. A single jet might take thousands of years to push through the cloud. A star might take millions of years to fully ignite. Webb allows us to freeze this motion and study it. It allows us to be archaeologists of the present. We're looking at a process that is happening now, but physically resembles the past. This duality is what makes the observations so mesmerizing. We are looking at the edge of space, but we are also looking at the edge of time. We are seeing a modern reenactment of the early cosmos. The golden eye of the telescope is incredibly sensitive. To give you a sense of its power, if you were a bumblebee hovering on the moon, Webb could detect your body heat from the Earth. It is this sensitivity that allows it to pick up the faint glow of a protostar 58,000 light-years away, buried inside a cloud of cold dust. As the telescope stares at these lonely outposts, it creates a bridge. It connects the human mind, evolved on a wet, rocky world in the metal-rich suburbs, to the primordial conditions of the galactic frontier. It connects the complex to the simple, the present to the past. The silence of the L2 orbit is profound. There is no air to carry sound. There is no wind to shake the mirrors. There is only the steady pressure of sunlight on the sunshield, and the slow, deliberate rotation of the reaction wheels keeping the telescope steady. In this stillness, the data gathers, photon by photon. The light from the edge hits the gold mirrors, bounces to the secondary mirror, and funnels into the instruments. It is a harvest of ancient light. And as the images form, we realize something comforting. The galaxy is not just a structure, it is an ecosystem. The edge is not a dead end, it is a frontier. It is a place where the galaxy is still growing, still trying to build, still pulling material from the void and shaping it into light. The coastline we spoke of earlier is not a jagged cliff, it is a marshland. It is a fertile delta where the river of the galaxy meets the ocean of the void. And thanks to the golden eye, we can finally see the life teeming in that delta. We have established the place, the edge. We have established the tool, the web. Now we must go deeper. We must descend into the clouds themselves. We must walk among these young stars and ask them what it is like to be born so far from home. We must understand the specific physics of solitude. What happens to a star that has no neighbors? What happens to a solar system that forms in the dark? The journey continues. We are moving from the wide-angle view to the close-up. We are going to drift down into the gravity wells of the Deagle clouds and witness the birth of stars in the extreme outer limits. The silence waits for us. The red glow of the infrared guides us. We are leaving the general and entering the specific. The golden eye has opened the door. Now, we must walk through it. We are now inside the cloud. The perspective has shifted. We have moved from the orbital height of the telescope, drifting down through the vacuum into the misty, turbulent interior of the Deagle clouds. Here, 58,000 light-years from the galactic center, the universe feels different. It feels older. It feels rawer. To understand why this place is so special, we must talk about the ingredients of the cosmos. In the busy, bright center of the Milky Way where we live, the space between stars is filled with a rich, complex soup. It is a soup seasoned by billions of years of stellar death. When a massive star dies in a supernova, it creates iron, silicon, oxygen, and carbon. It blasts these elements out into the dark, mixing them with the hydrogen gas. This dust, as astronomers call it, is crucial. It acts like a cosmic coolant. When a giant cloud of gas begins to collapse under its own gravity to form a new star, it heats up. Pressure builds. If the cloud gets too hot, the gas expands and pushes back, stopping the star from forming. But the dust, the heavy elements, absorbs this heat and radiates it away into the infrared. The dust calms the cloud. It allows gravity to win. It allows the star to be born. But here, in the extreme outer galaxy, the dust is missing, or at least it is very, very scarce. The Digel clouds are chemically primitive. They are almost pure hydrogen and helium. By all the laws of physics we usually observe, star formation here should be difficult. It should be inefficient. The gas should get too hot. The clouds should bounce back instead of collapsing. And yet, as we float through this red-hued gloom, illuminated by the penetrating gaze of the James Webb Space Telescope, we see that gravity has found a way. We see a young star known as a protostar. It is not yet a calm spherical sun. It is a violent, thrashing thing. It is hidden inside a cocoon of gas, but we can see its power. It is shooting out jets of material at incredible speeds, hundreds of miles per second. These jets are like cosmic fire hoses. They slam into the surrounding gas, creating shock waves that glow in the infrared. These structures are called Herbig-Haro objects. They are the tantrums of stellar infancy. And seeing them here, in this metal-poor wasteland, is a revelation. It tells us that the universe is stubborn. It tells us that gravity is relentless. Even without the coolant of heavy metals, nature finds a mechanism to shed heat. Nature finds a way to compress the gas. The presence of these jets confirms that the star is actively feeding. It is pulling material in from a disk, growing fatter and hotter by the minute. This scene is a window into the deep past. When the universe was young, just a few 100 million years after the Big Bang, there were no metals anywhere. The very first generation of stars, the primordial giants, had to form in conditions exactly like this. They had to form in pure hydrogen. For decades, astronomers have used computer simulations to guess how those first stars were born. They wrote code to simulate the physics of the early universe. But now, we don't need to guess. We have a laboratory. The edge of the Milky Way is a fossil. It is a pocket of the early universe that has survived, untouched, into the modern era. By watching this single star birth in the Digel clouds, we are effectively watching the birth of light in the ancient cosmos. The silence here is broken only by the silent roar of the jets. In the vacuum there is no sound, but the visual violence implies a deafening noise. The shock waves ripple out, pushing the nebula apart. It is a lonely birth. In the center of the galaxy, stars are often born in litters. The Orion Nebula is a nursery crowded with thousands of screaming infants. But here, the clusters are small. They are isolated. This isolation changes the destiny of the star. A star born in the crowded center is often jostled by its neighbors. Its planetary disk might be stripped away by the radiation of a nearby giant. It might be ejected from its home by a gravitational encounter. But a star born at the edge, it is born into solitude. It has room to breathe. It holds onto its disk. It evolves in a quiet, undisturbed vacuum. Webb's instruments, specifically the mid-infrared instrument or MIRI, have dissected the light from this lonely protostar. They have looked for the chemical fingerprints of the disk, and they have found something surprising. Even though the cloud is poor in metals, the disk around the star seems to have concentrated what little heavy material exists. We see signatures of molecules, we see carbon-rich grains. It seems that the star-forming process acts like a refinery. It gathers the scarce resources of the cloud and pulls them into the center, hoarding them around the newborn sun. This suggests that even at the edge of the universe, the potential for complexity exists. The ingredients for planets are rare, yes, but they are not absent. As we drift away from the protostar, moving back out through the wisps of the cloud, we are struck by the stillness. The galaxy behind us is a distant wall of light. The void ahead is infinite. This star will live its entire life, billions and billions of years, in this quiet frontier. It will likely never encounter another star. It will circle the galactic center in a wide, lonely orbit, taking hundreds of millions of years to complete a single revolution. It is a hermit star, a sentinel on the ramparts of the Milky Way. The science of the outer galaxy is the science of limits. How low can the density go and still make a star? How few metals can you have and still make a planet? How cold can it get before chemistry stops? Webb is answering these questions not with theories, but with pictures. It is showing us that the habitable zone of the galaxy, the region where stars and planets can form, is much wider than we thought. It stretches out into the dark. It stretches to the very brink of the intergalactic deep. The data streaming back to Earth from this region is changing our maps. We used to draw a line where the galaxy ended. Now we know the line is blurry. The galaxy fades out slowly, whispering its existence into the void for thousands of light years further than we dared to imagine. And in those whispers, there are worlds. This brings us to a new kind of question. A question not just of physics, but of experience. If stars are forming here, and if disks are forming around them, then planets must be forming too. What would it be like to stand on one of them? Let us perform an act of imagination. Let us fast forward time. The protostar we watched in the Dijal clouds has matured. It has blown away its cocoon. It has settled into a steady, yellow-white burn. The disk of dust around it has coalesced. The gravity has done its work, gathering the scarce crumbs of silicon and iron into a small, rocky world. We are standing on the surface of this world. The gravity is familiar. The ground is solid rock, cold and hard. But when we look up, the sky is unlike anything a human has ever seen. On Earth, our night sky is a tapestry. We are buried deep inside the spiral arm of the Milky Way. Every direction we look, we see stars. Bright ones, dim ones, clusters, constellations. The sky is crowded. It is a ceiling of diamonds. But here, on the edge world, the sky is divided. If you turn to the south, facing toward the galactic center, you see a magnificent, terrifying sight. The Milky Way takes up half the sky. But it is not a band, it is a fan. It is a massive, glowing shield of light that rises from the horizon and climbs to the zenith. You can see the spiral arms clearly, distinct ribbons of blue and gold wrapping around the central bulge. You can see the dark lanes of dust creating silhouettes against the core. It is beautiful, but it feels distant. It feels like looking at a city from a mountain peak 20 miles away. You are seeing the collective light of 200 billion suns, but you are not among them. You are outside. Now turn around, turn to the north, face away from the galaxy. The sky is black. It is not the speckled black of an Earth night. It is a deep, swallowing black. There are no nearby stars. There are no constellations to guide your ships or your stories. The nearest star might be 1,000 light years away, visible only as a faint, unblinking dot. Instead of stars, you see faint smudges, fuzzy patches of light. These are not stars, they are other galaxies. You can see Andromeda clearly, a small spiral coin in the dark. You can see the Triangulum galaxy. You can see the distant clusters of the Virgo supercluster. On this world, you are naked to the universe. There is no foreground, there is only the background. The psychological impact of this sky would be profound. A civilization arising here would not dream of traveling to the stars in the same way we do. For us, the stars are stepping stones. Alpha Centauri is just next door. Sirius is down the street. We imagine hopping from one to the other. But for the edge dwellers, the galaxy would be a singular object, a destination, the great light. They would not see themselves as living in the galaxy, but living alongside it. The journey to the nearest neighbor would not be a voyage, it would be an exile. The silence on this world is absolute. The interstellar medium here is so thin that the solar wind from the parent star races out unimpeded for vast distances. The heliosphere, the magnetic bubble that protects the system, is huge, pushing back the weak pressure of the intergalactic void. Life here, if it exists, would be starved of heavy elements. Biology needs carbon, oxygen, nitrogen, phosphorus. These elements are rare in the outer rim, so perhaps the life forms here are small, perhaps they are simple, or perhaps they are incredibly efficient, scavenging every atom of precious metal from the soil, cycling it with a precision that Earth life has never needed to learn. The Webb telescope cannot see these planets directly. Not yet. They are too small, too dim, and too far away. But by studying the stars, we can infer the planets. We know the architecture is there. And there is another aspect to this location, a safety aspect. The inner galaxy is dangerous. It is crowded. Supernovae go off frequently, blasting nearby worlds with deadly radiation. Stars pass close to one another, disrupting comet clouds and sending rains of death down on planetary surfaces. The supermassive black hole at the core flares up, spewing X-rays. But the edge is safe. It is the quiet countryside. There are no supernovae here to scorch the atmosphere. There are no rogue stars to disrupt the orbit. A civilization here could last for billions of years, uninterrupted by cosmic catastrophes. They would be the slow, steady watchers of the universe. They would have a front row seat to the collision that is coming. In about 4 billion years, the Andromeda galaxy will crash into the Milky Way. For a civilization in the inner galaxy, this will be a chaotic, sky-altering event. The night will be filled with new star formation, with exploding gas, with the merger of black holes. But for the edge dwellers, it will be a spectacle viewed from a safe distance. They will watch as Andromeda grows larger and larger in their empty northern sky. They will watch as the two great spirals begin their dance. They will be the archivists of the merger, recording the history of the collision from their lonely, stable outpost. This perspective, this idea of the view from the edge, changes how we feel about our own position. We often complain that Earth is in a boring part of the galaxy. We are not in the core, we are not in a glorious nebula, but we are realizing that we are in the Goldilocks zone of the galaxy itself. Not too crowded, not too empty, not too hot, not too cold. The edge is the extreme. It is the Antarctic of the Milky Way. Beautiful, pristine, harsh, and lonely. As Webb continues to stare into these regions, it is finding more and more anomalies. It has found globular clusters, tight balls of ancient stars orbiting in the halo of the galaxy. It has found streams of stars that look like ribbons, the leftovers of small dwarf galaxies that the Milky Way cannibalized eons ago. The edge is a graveyard of ghosts. When small galaxies get too close to the Milky Way, our gravity rips them apart. Their stars are strung out like pearls on a string. These stellar streams wind through the outer halo. So, our lonely observer on the edge world might not be completely alone. Occasionally, a stream of stolen stars might pass by in the dark, a spectral procession of refugees from a dead galaxy. They would pass silently in the night, a river of strangers flowing through the void. The Webb telescope is the first instrument sensitive enough to map these streams in detail. It is allowing us to do galactic archaeology. By tracing the motions of these outer stars, we can reconstruct the violent history of how the Milky Way grew. We can see the scars of past meals. The darkness of the edge is not empty, it is full of history, it is full of the debris of conquest. As we stand on this imaginary world, looking up at the distant spiral arms, we feel a sense of scale that is hard to hold in the human mind. The Milky Way is vast, but the space around it is vaster. We are coming to understand that a galaxy is not a hard-shelled object. It is a gradient of light that fades into the dark. And in that fade, in that twilight zone where the galaxy ends and the universe begins, there are mysteries that challenge our understanding of how structure comes to be. The Webb telescope has looked at the edge and found it active. It has found it alive. It has found it to be a mirror of our own past. The silence is not empty. It is waiting for us to listen. We have traveled far. We have drifted from the warmth of the inner solar system, past the cold giants of Neptune and Uranus, through the interstellar fog, and arrived at the desolate, beautiful rim of the Milky Way. We have watched stars being born in the silence of the digital clouds. We have imagined standing on a world where the night sky is half fire and half void. But there is one final shift in perspective we must make. We must understand why this matters not just for us, but for the entire universe. The edge of the Milky Way is not just a local curiosity, it is a mirror. When the James Webb Space Telescope opens its shutter and stares at the digital clouds, it is effectively calibrating its vision for something much larger. It is learning how to read the faint signatures of the first light. You see, the universe is a machine that recycles. It builds complexity over time. The galaxies we see in the deep fields, those tiny red smudges that existed 13 billion years ago, were very similar to the edge of our galaxy today. They were small. They were chaotic. And crucially, they were metal poor. They had not yet had time to pollute themselves with iron and dust. For years, astronomers have struggled to understand those distant ancient galaxies because they are so far away. Even with Webb, they remain tiny dots. We cannot see the details of star formation inside them. We cannot see the jets, we cannot count the individual protostars. But the digital clouds offer us a loophole. They are a local analog. They are a piece of the ancient universe that happens to be parked in our own backyard. By studying how stars form here, at the edge of the Milky Way, we are decoding the rules that govern the entire cosmos at the dawn of time. We are learning how the first stars lit up the dark ages. We are learning how the first galaxies assembled themselves out of the cooling gas of the Big Bang. It is a beautiful symmetry. To understand the furthest things, we must look at the nearest edge. To understand the beginning of time, we must look at the fringe of space. As we float here, observing the data streaming from the telescope, we realize that the Milky Way is not a finished object. It is still growing, it is still eating, it is still breathing. The gas at the edge is slowly spiraling inward. It will eventually travel down the spiral arms, moving from the quiet countryside to the busy city. It will mix with the heavy elements. It will become part of new generations of stars. The hydrogen atom that sits today in the cold Digel cloud might, 5 billion years from now, be part of a drop of water on a new planet in the Orion Arm. Everything flows. The edge feeds the center. The center enriches the edge. Webb has revealed this connection. It has shown us that the galaxy is a single breathing organism. The extreme outer galaxy is not separate from us. It is the reservoir of our future. It is the raw material waiting to be shaped. And it brings us a sense of humility. We often think of the Milky Way as our galaxy. We map it. We name its arms. But we occupy such a small, specific niche within it. We live in the metal era, in the heavy, dusty, complex part of the galaxy's history. But out there, in the rim, the hydrogen era persists. The simplicity of the beginning is still there, preserved in the cold. The images Webb has returned, the glowing red filaments, the sharp bow shocks of the jets, the glittering clusters of young stars are more than just data. They are a bridge. They connect the here and now with the everywhere and always. The silence of the outer rim is the silence of the library. It is where the records are kept. And for the first time in human history, we have a lantern bright enough to read the books on the furthest shelf. As we prepare to leave this place, to turn our imagination back toward Earth, we carry with us a new map. A map that doesn't stop at the spiral arms. A map that fades gently into the dark, filled with hidden stars and silent clouds, stretching out to meet the rest of the universe. The edge is not the end, it is the beginning of the rest of the cosmos. And so, we return. The journey back is faster than the journey out. We let our minds drift inward, carried by the gravity of home. We leave the lonely protostars of the Digel clouds behind. We leave the vast starless skies of the rim worlds. We drift back through the thinning mist of the outer arms, past the Cygnus rift, past the Perseus arm, back into the warm, dusty, crowded embrace of the Orion spur. We see our sun ahead, a familiar yellow star, stable and bright. We see the blue marble of Earth, suspended in a sunbeam. We have returned, but the sky looks different now. Before this journey, when we looked up at the Milky Way, we saw a band of light, we saw a ceiling. But now, we see a shoreline. We understand that we are living on an island universe, as the philosopher Immanuel Kant once called it. And like any island, it has a coast. The work of the James Webb Space Telescope has illuminated that coast. It has turned the dark edge into a place of texture and depth. It has reminded us that the boundaries of our home are soft, not hard. The title of our story was James Webb finally looked beyond the Milky Way's edge. And it did. But what it found was not just beyond. It found that the edge is a place of its own. It is a place where the rules of reality are tested. It is a place where nature creates light in the most difficult of circumstances. It is a testament to the resilience of the physical universe. In the coming years, Webb will look again. It will stare longer and deeper into these outer regions. It will find more clusters. It might even find the faint heat signatures of planets forming in the metal-poor dark. Every image will be a new verse in the long poem of the galaxy. But for now, we rest with the images we have. We rest with the knowledge that we are not enclosed in a box. We are floating in a vast interconnected ocean of gravity and light. Tonight, if you can, go outside, find a dark place. Look up, find the band of the Milky Way if the season is right. Trace it with your eyes. And then, look away from it. Look into the darker patches of the sky. Look toward the constellations that face away from the galactic center, toward Auriga, or Gemini, or Perseus. When you look in those directions, you are looking toward the edge. You are looking toward the Digel clouds. You are looking toward the place where the stars thin out and the great void begins. It does not need to feel lonely. It can feel spacious. It can feel open. The silence of the edge is the silence of potential. It is the silence of things that have not yet happened, of stars that are just beginning their long, slow burn. We are the dreamers of the inner galaxy, looking out. They are the sleepers of the outer edge, just waking up. And between us lies the vast, beautiful spinning structure of our home. A spiral of light in the universe of dark. The telescope hangs in its orbit, 1,000,000 miles away, its gold mirrors facing the cold. It waits for the next command. It waits to uncover the next secret. But for us, the journey is complete. We close our eyes, and we drift in the quiet knowledge that the edge is not a wall. It is a horizon, and horizons are meant to be explored. Good night.